Right, we're gonna go ahead. Ooh, yeah. All right, we're gonna go ahead and get started. So first off, welcome. Hopefully you guys have all had a good weekend and things at school are actually going well. I got a lot of your messages and I got a lot of your emails just saying, congrats and everything. And I just wanted to take the time to say I greatly appreciate you all who reached out and just letting you know that the family here is doing great. Wifey's doing good. Baby's doing well. Everybody's here back at home. So we're just all resting and trying to get adjusted to being new parents. So, exciting time for us. But even though I am not there physically in the school building, I still want to make sure that you guys get everything that you need in order to still be successful while I'm still out. So, that being said, we're going to go ahead and do like these video recording lessons so that way you can still get all the information you need in order to be successful throughout this next unit that we're going to start today. And if you have questions, yes, the videos here are going to be helpful for you, but do not hesitate to reach out. You all should have my email. You all should have my number by now. So don't hesitate to ask those questions, no matter if you feel like it's going to be bothering me or whatnot. Please do, because I want to make sure that your answers or your questions are answered. So that said, all right, so we're going to begin Unit 3. So while I was in school, we talked about Unit 1, which focused on polynomials, how to add, subtract, multiply, divide, all that type of stuff. And Unit 2 kind of looked at complex numbers. So the good news is that a lot of those things that we did in the first two units, you don't really need whatsoever in this. So you can kind of breathe a little bit if those weren't your strong suits or if those were topics that you weren't really comfortable with. But as we start Unit 3, we're going to begin looking at two new types of functions. We're going to look at a function that is called an exponential function, and then we're going to look at another type of function that is called a logarithm. So we're going to spend the first half of Unit 3 just really focusing only just on exponential functions. And then eventually, after maybe a couple weeks of dealing with that, then we will move on to that second type, which is logarithms. So we're just going to focus on the first one throughout these next couple weeks. So this first video recording is going to focus on unit or lesson one of unit 3. All right. So all of you should have gotten my packet by now, hopefully by either the sub or somebody else who's in my spot. So please make sure that if you have not gotten the unit 3 packet, please make sure you grab that as soon as possible because you're going to need that, especially when I'm going over these notes for each of the lessons. And you can always feel free to go back to them anytime in case if you miss a school day or if you're out or anything like that. So it's going to be pretty easy to catch up. You just need to make sure that you're watching these videos, making sure that you're doing the assignments that I might give or work on the exit tickets that I give as well. So that being said, we are going to go ahead and we are going to start on lesson one. All right, so you should probably see this on your screen as well. This is just a copy of my notes that we're going to look at and do together. So the first thing that you guys have, which is just again, we're going to be introducing exponential functions, but to help us get started with that, I do have a do now for us. So it says that in this unit, like I mentioned before, we're going to go over these two types of functions. But before introducing these types, you want to review some things that we might have learned from Algebra 1. So what I'm going to do, or what I'm going to give us time to do, is that your do now has two questions. You have a function here, y equals 3x plus 2. And all I am asking you to do first is to fill in this chart. So I give you a couple x values here, and all you're doing is just plugging your x value into the function, just like I did here. And when you plug it into the function, I want you to tell me what number you get. So in this case here, I did 3 times -3 plus 2. If I use a calculator or did that in my head, I should get -7. So I want you to do the same thing for the rest of this chart. And then once you have filled that in, number two at the bottom of the page is asking you to graph it. So that I want you to go ahead and take those numbers that you got from the table above, and then I want you to go ahead and graph it onto this plane listed here. I would say go ahead and pause this video now, and when I come back, I'm going to show you what the answers are and show you what the graph should look like as well. So go ahead, take this time, go ahead and pause the video. All right, we are back. So, if you went ahead and actually filled out the chart, you should have got the numbers that I should have got on my page as well. So when I plugged in all these x values into my function, I should have got -4, -1, 2, 5, 8, and 11, just going down the line. So if you did not get those, just make sure you go ahead and correct yourselves as well. Now, what we're going to do is that we're going to take this information and we're going to graph it at the bottom of the page. So if we go to the bottom of the page here, we're going to go ahead and use some of those points that we found on using our chart at the top of the page. So this here, this is going to be our x-axis. And this here going up and down, this is going to be our y-axis. So if we look at the chart, first off, we said here that when x is -3, our y value should be -7. So if I go here, I'm going to go -3. So I'm going to go 3 to the left, 3, and then I'm going to go 7 down. So 1, 2, 3, 4, 5, 6, 7. So that means that I'm going to have one dot right here at the bottom of the plane. Then if I want to move around, I can, just go straight forward. I can go to my next point if I want to, or I can skip around. But I'm just going to go ahead and just go down the line. So I said here, or we said here that when x is -2, our y value is -4. So that means same idea. I'm going to go 2 to the left, and then I'm going to go 4 down. So I have another point right here. All right, then our next point we have is -1, -1. So we go 1 to the left and then 1 down. So if we were to continue this pattern, right, we have 0, 2, so we're going to have a point eventually right here. We're going to have 1, 5. So 1, 5 is right around here. And then 2, 8, which would technically take us off the grid a little bit. And 3, 11, so on and so forth. But here, if we were just to connect our dots, we would then create our line needed to represent this function. So that's our graph. All right, so all the stuff that we just did in this do now should not be anything that's new to us. This is stuff that we should have seen back in Algebra 1. And so this should be like a little good mini refresher on just how we look at finding lines. So that being said, we're going to take this information and then we're going to go ahead and look at page 2. So let's move to page 2. So we're still going to use this equation from the do now, and we want to answer some of these questions here at the bottom. So first off, we have a function, we have a line. So some of the things that we need to identify, we need to identify the slope, and we need to identify the y-intercept of this function. All right, so either by looking at the function or you can look at the graph that we just did together. First thing we want to do is find the slope. Now, hopefully, take 5 seconds. You should have an idea or guess what the slope is in this case. And for us, we're going to say the slope is 3. That's what this number here represents, right? If we remember, when it comes to equations for lines, one of the ways that we learned it is using the formula y equals mx plus b. Okay, so remembering this, we said, hey, this part here, m, this represents your slope. And this variable here, b, this represents your y-intercept. Okay, so using that same logic in this equation here, okay, in this case, this 3 represents our slope. So that's why I wrote it here. And then our y-intercept is this last number, which in this case represents as 2. Now, the y-intercept is just not a number, it's a coordinate, it's a point. So we got to write it as a point. So our y-intercept, in this case, what we're going to write is 0, comma, 2. That tells us that when our x value is 0, like if I plug in 0 for x in this function, I should get a y value of 2. And that should make sense because 3 times 0 is 0, and then 0 plus 2 is 2. Great. So we have our slope and we have our y-intercept. Now, the other thing that we want to take into consideration with lines or graphs is that we want to identify, well, what's the domain and what's the range. So if you do not remember from Algebra 1 what exactly it means when it talks about domain and range, domain, what we're focusing on is that we're focusing on x values. And the range is the opposite. We're focusing on y values. So when we're talking about domain, we're really just asking ourselves, if this is our function up here, we're just trying to think, can I plug in any number for x into this function? Okay, so think to yourselves, okay, can I plug in 0 here? Yeah, you should be able to plug in 0. We actually did that in order to find the y-intercept. Can you plug in a positive number for x? Yeah, I mean, I can plug in 1, I can plug in 5, I can plug in 20, a million, whatever. I can plug in a positive number, and I can plug in any negative number I want for x as well. So that being said, if I can plug in a positive number, a negative number, or 0, that means that our domain, in this case, we're going to say is all real numbers. And again, that represents that I can plug in any number I want into this function and I'll get something in return. I'll get an output. Now, the range, kind of like the same idea, we're just trying to think to ourselves, if I were able to plug in any x value into this function, what are the list of, or what are the potential options of y values that I can get in return? So thinking to ourselves, like, if is there a number for x that I can plug in to get y equal to 0? Yes, you're able to find that out, or you're able to do that. Is it possible to plug in any value for x and get any positive number? Yes, that is also possible as well. And same thing for negative numbers. I can plug in any negative number I want in here, and no matter what, I'm able to get any negative number as an output as well. So in this case, similar to domain, our range is all real numbers. To help us even visualize that as well, if we want to refer back to the graph from the do now, I'm just going to go back here for a second, and I'll go back. If we look at the graph at the bottom of our do now, same idea. With domain, I can plug in any number on this x-axis that I want. I didn't plug them all in, but in theory, if we did the same approach as we did up top, I can plug in any number on this x value to get something. And similar to that, as my graph is going to be continuing going up on one side and continuing to go down on another. So that means that no matter what, my y values are just going to go either to a positive infinity or it's going to go towards negative infinity. So that's why also we can say that our range is all real numbers as well. So because of these key features that we found from um, this equation, using the slope, identifying the y-intercept, the domain and range, all these things, when they come together, this equation, we remember it is known as slope intercept form. So equations of lines and slope-intercept form best friends in the world because that helps us with identifying things like domain, range pretty easily, but also at the same time, it helps us with identifying quickly, hey, what's the slope and what is the y-intercept? Now, unfortunately, we are not dealing with just equations of lines moving forward. No, we are going to be looking at, like I mentioned before, a new type of function. And the first type that we're going to start with today is exponential functions. So here at the bottom of page 2 of your notes, we kind of have an example problem or a model. Okay, so what we're going to look at here is that we have kind of like an example problem. It says that we have a population of 50 bacteria cells. And what we know is that these bacteria cells, they double in size every hour. Now, the equation for this model has actually been given to you. It is this function here. Now, looking at this function, what we just want to do first is that we just want to identify the meaning of as many parts to this equation as possible. So we would just want to figure out, well, what does this 50 represent? What does this 2 represent? What is x in this case? And what is y? Like, what do they all represent in terms of this problem? So what I want us to do is that I want us to take a couple minutes, go ahead and pause this recording when I'm done with these directions, and I want you to just write down what you see from this function and what do you think these numbers or what do you think these variables will represent. So go ahead and pause the video, and then when we come back in a couple of seconds, we're going to go ahead and talk about what this function here is saying. All right, we're back. So what we're trying to do here is that we're looking at this function and we're just trying to identify the parts of this function and talking about, well, what exactly this all means. So let's go ahead and break it up. Let's start with this number here, 50. Well, 50, 50 is listed here. We have 50 bacteria cells, right? This is what we started with. So we're going to say this represents our starting population. So we began with 50 bacteria cells, right? And what the problem said also is that the population doubles every hour. So doubles, that should represent doubling, meaning what? It should mean 2. That's where this 2 here represents. So this 2 we get because we know that our population is doubling. And we also know how often our population is doubling. It tells us that it doubles in size every hour. Okay. So since we know that we're doubling every hour, okay, x, which is our variable here, our independent variable, x is going to represent how many hours that pass. Okay, so that's what x represents in this function. And then the last thing we just need to talk about is, okay, after all of this, what does y represent? Okay, so in this case, all of this, y represents, well, what is going to be our population after x hours passing. So this is just telling us that, okay, after we give a value here for x, that tells us again how many hours passed. So if we're saying x is 2, that means that 2 hours passed. And so we're trying to figure out, okay, what is my population after 2 hours passing? And then that would be what in this case y would represent. So we've kind of broken apart this function here. We know what each of these components represent in context to this model problem. So now what we're going to do is that similar to like the do now, we're going to take this information. So I'm going to move to page 3. I'm going to move this to the side. And so now we're looking at page 3 where we're still looking at this function. And similar to the do now, we have some x values that I want us to go ahead and plug into this function and then see what we get. Don't worry about graphing just right now. What I want us to do is that I just want us to take maybe 3 or 4 minutes on your own. I want you to go ahead and try to fill in this chart, get a grab a calculator or use a calculator on your phone. It does not matter, but use a calculator to help you out with trying to figure out, well, what are going to be our outputs or what are going to be our y values after plugging in these x values. So go ahead, pause the recording. And then when you come back or when you unpause it, you're going to see this table filled in. Okay, we are back. So looking at this table here, so I went ahead and filled it out for us. So see if your numbers match what I have on my paper as well. So once we plugged in all these different x values into our function, we got all of these y values here. So when x is -2, we plug -2 up here for our exponent, and we plug this into our calculator, we get 12.5. If I scroll down or go down for a moment, if I plug in 3 for x, let's say, then that means that for our function, we have 50 times 2 to the third power. And if I plug all this in, I got 400. So this should be our table. We're going to use this now to look at, okay, how are we going to graph this function? So similar to the do now, we have a coordinate plane here at the bottom. And what we're going to do is that we're going to take some of these points that were given to us, and we're going to graph them here. So in this case here, I am actually just going to start with probably the easiest one, which is this one. So we know that when x is 0, our y value is supposed to be 50. Now, in this case here also, we don't have 50 boxes, right? We can't be at 0 and then go up 50 because we don't have that. So in this case, what I'm going to do is that I'm going to scale it, okay? And how I'm going to scale it is that our y value, as we go up and up, I'm actually going to go up by 50s. So like this is going to be 50, this is going to be 100, 150, 200, 250, 300, 350, and then so on and so forth. So again, I'm just scaling these by 50, and the reason why I'm doing that is just because the graph will be easier for me to do because of that. So in this case, when x is 0, y is 50. So we have a point actually right here. If I were to go back to our table here, it says that when our x value is 1, our y value is supposed to be 100. So if I go 1, so I'm going 1 to the right, and then if I go up 100, that means that I'm going to have a point right here. Then when x is 2, our y value is 200. So I'm going to go 2 to the right, and then I'm going to go up to 200. And then when x is 3, our y value is 400. So 400 is a little bit off the grid here, so I'm just going to draw a point here at the top. Now, if I were to go in the negative direction, so if I'm using these numbers here, it says here that when x is -1, our y value is 25. So note here, there isn't a 25 necessarily on our scale, but 25 is actually half of 50. So I'm just going to put a dot right here, and that represents, well, 25 since we're kind of in the middle. Same idea. When x is -2, our y value is 12 and a half. 12 and a half is half of 25. So similar to what we did before, I'm actually going to draw a dot just right above the x-axis, but not necessarily touching it. And if I were to continue this process, what's going to happen is that as I move further and further to the left here, these numbers are going to start getting smaller and smaller, and they're going to get really, really close to this x-axis here. So if I were to continue this process, what turns out, and if we want to go ahead and connect the dots, is that the graph for this function is going to look like this. Okay, so this is your first graph of an exponential function. So congrats to you. All right, so we have created the graph of this function based on the model problem. And if we look at the bottom of page 3 now, what we're going to look at is taking all this information. And again, now we want to identify, based on the graph, we want to identify the domain and the range. All right, so let me zoom out for a second. That's a little bit too much. Okay. Now, here's our function. We're trying to identify the domain and the range. So again, if we look back at our notes from page 2, it says domain deals with x values or y values. And if you look, you should see that it says that we're dealing with x values. And the range, on the other hand, deals with the y values. Now, again, you don't have to keep writing x values and y values. You can skip that part if you need to. I'm just writing it here for us as a refresher. Now, domain deals with x values. We were just trying to ask ourselves, what values for x can I plug into this function? Now, if you want to look up for a second, we plugged in negative numbers, we plugged in positive numbers, and we plugged in 0. So what this tells us is that we can actually plug in any number we want into this function. So that means that when it comes to our domain, the domain for this function is still all real numbers. Now, my question to you all is that the case for your range? Can we have all real numbers for our range? And it turns out the answer to that question is no. The reason why is because if we look at our y-axis here, not every single number on this y-axis is being reached. What I mean by that is if we look at our graph, it's all the way up here. I cannot hit any of these y values here at the bottom of our graph. There's no number that I can plug into this graph that will make my y value equal to, let's say, -5. So there's no way I can hit anything beneath here. So that being said, that means that our range is kind of limited. So we got to figure out, well, what is our limits? Like how far above can we go and how far below can we go? So if we look at this graph here that we created, this line to the left is getting closer and closer to the x-axis, but never necessarily touching it, but it is getting closer and closer to it. So if we're getting closer and closer to the x-axis, what is the y value going to be? So if we're getting closer and closer to this x-axis, that means that the y value is actually getting closer and closer to 0. So that means that like our lower bound or the smallest number that we can potentially reach with this graph is 0. But if we go towards the right, we see that this arrow is pointing up, which tells us that it's going to keep going up and up forever and ever, which means that it's basically going to go off towards infinity. So that means that our range is going to be from 0 to infinity. So these are all the potential y values that could be achieved or reached from this graph. So we can write it as 0 to infinity, or if you want to write it in terms of an interval, you can write it as 0 comma infinity. However you want to write it, they're both the same thing. But just keep in mind that if you write it out in this way, or if you see it in this way, they both mean the exact same thing. So I just want you to be aware of that. So you've kind of had a taste of exponential functions, right? We've created a table together about what these values are going to look like, and we took this table and we created a graph based off of it. And looking at this graph that we did together, we were able to identify the domain and we were able to identify the range. So now what we want to do is that we want to compare these answers side by side. So what I have here is, let me go ahead and zoom out a little bit. Okay, as far as we go. So on page 2, we identified domain and range for that line that we did together. And on page 1 in the do now, we did the graph for it. On page 3, we took an exponential function. We did the same thing. We created a table and we actually graphed the function using the points given to us on this table. So now if we move to page 4, what I want us to do is that I want us to look at question number 5 here at the top. And then what I want us to do is that I want us to list any similarities or differences that we notice between the graph from the do now and the graph that we just created on page 3. So take 4 minutes, go ahead and see and just write out any similarities you see between those two graphs, the graph on page 1, the graph on page 3. Just write down what are the same, what is different between them, and then when we come back, we'll talk about it. All right. So we're back, and some of the things that you might have noticed in terms of similarities, okay? You might have noticed that from both functions, both of them have the same range. Or you might have noticed, just simply being straightforward, you might have noticed that some of them or both of them pass through the x-axis. Okay, so that's another plus. Cool. So now what we're just trying to figure out is what is different about these two functions. So some differences that you might have noticed. The most or the biggest difference is they have different ranges. Okay, so they have different ranges. Or if you were just looking straight at the graph, you might have noticed also that one graph is a straight line versus the other that was, a curve. Okay, and that should make sense because we have two different types of functions. So because we have two different types of functions, we're going to have two different types of graphs. Okay, so the first function that we had from the do now was a linear function. All right, and just kind of generalizing it, right? We already know the equation of a linear function. We had that from before, y equals mx plus b, where in this case, m represents the slope. Okay, we call it the slope. You might say rise over run, or you might say that it is your rate. However you want to say it, it's fine. So m is your slope, And b in this function is your y-intercept. You can say it's your y-intercept, or another phrase that might be used is initial value. So that's a line, okay? And now what we're going to focus on is exponential functions. So these types of functions are written a little bit differently, or they're written in a different way. And so the exponential function, the equation for that, like the general equation, we're going to say y equals a b, where note here I wrote b in parentheses, and the exponent here is x. So we have y equals a times b to the x power. Now, in this case, a and b represent something a little bit different. It actually turns out that in this exponential function, a, that represents your y-intercept. Or again, this will represent your initial value. B, on the other hand, in this equation, it is not the y-intercept like how it is in a linear function. In this case, excuse me, B represents what is called your growth factor. Okay, so this is how we kind of break down a linear function, and this is how we break down now an exponential function. So looking at these two equations side by side next to each other, you might notice a couple of things. You might notice, well, yes, they both have a y-intercept. Cool. It's just in this case, for linear functions, that's your b, and for exponential functions, this number here, a, represents that for you. But we do have some differences between these two functions. One difference that you might notice is that the linear function has a plus sign, and in your exponential function, you don't have that. Okay, so that's just something that you can see off the eye. But what we might notice is that instead of slope, what we have for exponential functions is that we have growth factors. So this piece here is going to be helpful for us because that tells us, for example, if something is, doubling, tripling, being cut in half, or whatever, after, every single time some type of time has expired. Okay. And what you also might notice, the key difference between these two functions is that in that second one for exponential functions, you might notice here that x is used as an exponent. Now that might throw some people off that, okay, my x is not necessarily something that I'm raising to a power. X is actually the exponent itself. That is telling us what I am actually going to be raising some number by. Okay, so it's a little bit the opposite of what we've kind of maybe been dealing with from before. And so that might throw us a little bit off, but I want us to take this time to see here that that's nothing that you should be concerned or scared about. That's just going to help us with identifying, well, what exactly our graph is going to look like. So it's nothing that you should worry about. Okay, so the last thing that we got here is that we just want to take this time going over everything that we just did in this lesson, and we're just going to write these vocab words from the specific lesson. All right, so that way you have the central place that you can refer back to just to go back and look at, okay, If we're talking about domain and range, or if we're talking about exponential functions, this is exactly what it is that I'm talking about. All right, so that being said, we're going to go ahead and look at the first one. Now, when we're talking about exponential functions, right? Simply put, we're going to say the definition for this is that an exponential function is a function where the variable is an exponent. Okay, so if I go back up here, x, that is our variable. That is my exponent, so that's why it's an exponential function. Okay, now domain and range, we've been talking about this throughout the lesson, but just to have a clear-cut definition listed here for us, we're going to say domain is all possible input values. Basically, what I'm saying here is that domain is numbers we can use for x. Right? So that's the domain. And then the range, the definition we're going to say is all possible output values. Or really, what I'm referring to is that range is just numbers we can get for y. So, congrats. We got through our first lesson, which is introducing exponential functions. So again, we are still going to be practicing with this throughout this week and next week, where we're going to look at more exponential functions with graphs and eventually computing them and things like that. But we're going to take this information from these notes that we took today, and we got two things that we got to do with it. So the first thing that we're going to look at is page 5. So go ahead and move to page 5 in your packet. So I'm going to move this off to the side. Give me 1 second as I get myself together. So on page 5, which is right here, we have a few independent practice problems. We only got about 4 of them here, actually. Okay, so we have 4 independent practice problems. Now, what we want to do is that we want to look at each of these problems, and we want to take these exponential functions, we want to graph each of them, and then what we want to do is that we want to identify the domain and the range of each of these graphs as well. Okay, so I'm going to do one problem here for you so that way you have an idea of how to do the other 3. And then once I get done with this problem, your goal is to make sure that you finish the other ones listed. So for this first one, we're going to do number 1 together. You have a function y equals 4 times 2 to the x power. Okay, and what we want to do first is that we want to go ahead and we want to graph it. So to help us with graphing, what I would suggest doing, and you should do these for the other problems as well, is that we're going to create a table, just like we did for the other problems in the notes. So I'm going to give you a couple of points, and you can actually use these same exact points as well throughout all of these other problems. We're going to use the x values -2, -1, 0, 1, and 2. All right, and so these are your x values, and we're going to take each of these x values, plug it into this function, and see what we get. So in this case here, if I plug in -2, In my calculator, I need to plug in 4 times 2 to the exponent of negative 2. And if I were to do that, I actually would get 1. So if I plug in negative 2 for x here, that means that my y value is going to be 1. If I plug in negative 1 into this function, I'm going to get 2. If I plug in 0 for x, I'm going to get 4. If I plug in 1 for x, I'm going to get 8. And then lastly, if I plug in 2 for x here, I'm going to get 16. Now, if you're still confused on how I got these numbers here in our y column, I would suggest, taking a little bit of time to plug these numbers into your function and just make sure that your numbers match what I got here. But I'm going to go ahead and take this information and move forward, and I'm going to go ahead and start looking at creating the graph based off of this. Now, similar to what we did for the exponential function in our notes on page 3, obviously, yes, this goes up to 7, but similar to like what I did before, I'm going to scale it a little bit. So in this case here, to scale it and make it look better, I'm going to go by twos. So I'm going to go 2, 4, 6, 8, 10, 12, 14. So I'm just going up by twos here on my y-axis. Okay. Now, we know, just taking this information, we know that when x is 0, our y value is 2. So we have a point right here. We know that when, oops, sorry, not 2. It says here that when x is 0, our y value is 4. So forgive me, we don't have one here. We actually have one right here. All right. We know that when x is 1, our y value is 8. When x is 2, our y value is 16. So we're going to go slightly above the grid here. If I go in the negative direction, it says that when x is negative 1, my y value is 2. So I'm going to have a point actually right here. When x is negative 2, our y value is 1. So that means that we're going to have a point right here. So if I were to connect these dots, what happens is that our graph is going to look like this. For the first problem. So that is our curve. Now, looking at our curve, again, similar to before, we are trying to identify the domain and the range. So again, domain, your x values. Looking at what we just did in terms of that table, we had negative x values, we had positive x values, and we had a 0 x value. And no matter what we use, we got an answer every single time. So for that reason, our domain here is all real numbers. Now I can write numbers, but I just use the number sign for that one just to make it a little bit easier for me. All right. And then for your y values, okay, note here that similar to what we saw from before, you should see here that with your graph goes nowhere beneath the x-axis. So there's no way that I can hit any of these y values beneath the x-axis. So that means that our range, we're limited. If we look at the arrow on the left, it's getting closer and closer to the x-axis, which means that the y value that represents the x value or the x-axis is 0. So we're going from 0, and then on the right side, our arrow is pointing up. So that means that we're going to keep increasing, or our y values are just going to keep increasing all the way up to infinity. So that means that our range is going to be from 0 to infinity. So we can say it like this, or if we want to write 0 to infinity, that is also fine. Whatever you're more comfortable with. Okay, so similar to what I did for number one, you're going to do the same thing for questions two, three, and four on this page. All right. Now, after you get a couple of practice problems in for this, there is one more assignment that you have. There is, if you look at the very bottom, and I kind of have it somewhat highlighted on your page, you should notice it on yours as well. It says that, excuse me, it says that you need to make sure that when you're done with these independent practice problems, be sure that you complete the exit ticket as well as it is on Illuminate. Now, this is where I need you all to pay a little bit of attention to in terms of directions for this exit ticket. Because depending on what day you have Algebra 2, you're going to have different access codes in order to get to the exit ticket. Okay? So, if you are an A day, meaning that if you have me periods one, three, or four, so A days, in order to get to the exit ticket uh, for this lesson, you need to go on Illuminate. There is a code for you. The code for you all is this here, MXRMYBB. So if you have me on an A day, that is your access code to get to the exit ticket, and that is how you're going to be able to take it. For you all, this is going to be due at midnight on, what is that, the 29th? So basically, it's due at Wednesday at midnight for my A days. For my B days, so if you have me fifth, sixth, or seventh period, your code for uh, for your exit ticket is RWBVTW4. So that is your exit ticket. And for my B day classes, your exit ticket is due at midnight on October 30th. So it's due at Thursday on midnight. All right. So this is how you can access the exit ticket anytime, anytime you want. And my bad for my B days in case you didn't see that code. I have it here at the bottom now. But you need to make sure that this is completed before the next class period that we meet. Okay. So you need to make sure that this exit ticket is done, and you need to make sure that the independent practice problems on page 5 are completed by the time you come back to class. I'm going to make sure, or I'm going to ask that whoever is in my room, whether that's a sub or that's another teacher, I'm going to ask them to check to make sure that you completed page 5, and they're going to send me a report on who did it and who didn't do it, so that way I can give you those who did complete this, I can give you credit for it. Okay, so please make sure that you have those two things done. Otherwise, that is it for lesson one. This is something new for both for all of us, so I hope that um, this wasn't super boring, or this wasn't something that you kind of expected. I'm gonna try to make it a little bit better moving forward. And again, if you do have any questions about anything, whether it's the lesson that we just went over, or just like anything that we did in the last unit, especially like the test that you guys took, I'm still going to be working on grading that, so I should probably have that done by Halloween time. So if you have questions about that, or if you just have questions about lesson one or just unit three down the road, my email, text me. I'd probably say text me. That's the easiest way because I can respond back quicker. But you have access to me anytime you need it. Otherwise, have a good time, enjoy, and I'll see you for the next lesson in a couple days.